you ready? You done chewing? Don't take another bite. Don't take another bite. Okay. All right. Are you ready? Denny, are you ready? Okay. So, class.
Yes.
Thank you. All right. So now I know you guys got to keep it down a little bit. Too excited today. Okay. So we are continuing indefinite integral and substitution method. We are picking up right about here. Okay, so we already talked about how to do our subs and what's going to tell me that I'm going to have a substitution here. You guys recall? What is it that's going to tell me I should probably do a sub? What rule? Chain rule. If I look at it and I see, hey, that's going to be a chain rule, then I'm probably going to have a substitution. Okay? Yes. All right, so now from right here, this one, okay, it's not a chain rule. This one is a quotient rule. But I can do this using long division, and that's another method that we will learn in calculus 2. That one's like way off though. That's just a longer way to actually do these problems. But this one right here is also going to be a substitution. Now, remember, when we're using substitution, don't we take the derivative, right? We take the derivative, don't we? Say yes.
Yeah.
Okay, so I take the derivative, but now which one of these do I want to use to substitute for the other?
The first one? Wait.
Do you want the top or the bottom?
Turn the bottom to the derivative.
This one right here, the bottom, right?
Yeah.
I want to sub the bottom because when I take the derivative of an x cubed, I get x squared. And that's key. That's what I'm looking at. Those are my puzzle pieces that I'm looking to be like, okay, I know when I sub, I'm going to take the derivative, so my degree should be one less, so that should help me out. So let's say, let me see, u is equal to 4x cubed minus 1. And then when I take my derivative, it turns into du is equal to 12x squared
Oh, it's square.
dx. Thank you. That's what I'm looking for.
Oh.
Can't forget that one. Can't forget that one because that's part of my substitution. That's part of my substitution, that when I take my derivative, I'm saying I'm taking the derivative in terms of x. That's where I get my dx there. So, is that exactly what I need there? Say no. It's not really there though. But let's see if we can actually use that. Let's get rid of that 12. How would I get rid of that 12?
Like 12 intervals.
Just divide by 12, right?
Oh, yeah.
I gotta divide by 12 first because I'm not ready to do the substitution. So I should have, so on bottom, I get, bottom of my interval is just u, and the top, I'm going to replace what? Okay, x squared with, right? So, right there, with just du over 12, isn't it? So, this right here is going to go in place of this right here. Not the 5 though, right? Not the 5. So, I'm going to have, so by taking that, it's going to be 5 over 12, right? Because that 5 is still out there, and that's going to be du. Does that make sense, or is that nonsense?
Nonsense.
Nonsense?
I'm trying to look at mine.
Okay, so I'll back up slightly. Okay, are you okay with my x squared being gone?
Oh, I'm just wondering where the 12 is in the du over 12 thing.
See this right here?
Yeah.
Right? I got rid of this because I want just x squared dx, right?
Yeah.
So that means that right here I'm going to have 5, right? Times, okay, I'm replacing all of this, right? All of that is going to replace with this. So that's going in place now.
What's
So
the
du over 12.
Okay.
Because this used to be my x squared dx, right? So now it's just going to be du over 12. And do a little bit of math there. Can I take the 12 out? Yeah. So that's why it became the 5 over 12. Yes? Okay, better? And all this is still over u. And there we go. And continuing that pathway, so I'm going to end up with the 5 over 12. But since it's on the top of my fraction, isn't that a multiplier? So it's 5 over 12 times du, isn't it? Say yes. What would I do if I only had a 5 right here? Wouldn't I just move it out front, right? Because that's a common factor. But this time I have a 5 over 12, don't I? So can I move the 5 over 12 out front? Yes. Because it's still a common factor, isn't it? It's the same as 5. It's just instead of saying it's just right there, just a integer, I now have a fraction. So I treat it the same way. So I would normally just pull the 5 out, but since I have a 5 over 12, I can pull that one out too. So it's going to be 5 over 12 integral of du over u. Denny, did you get lost? Okay, since you missed the last... No, you were here for subbing, right? You were here when we started this U sub, right?
Yeah, he
No?
was there. He just missed the exam.
You were here Monday, right?
Were you here?
No, you weren't. You were brown slip Monday. That's why.
Oh, really?
Okay.
Yeah.
So yeah, so you missed out on what this actually is and how we're doing it. Okay, so you're gonna have to go back and for that video, or when you come in an advisory, I'll see if I can help you there. Okay. All right. So right here, all this is going out front. Du. Now, isn't the du just the same as saying 1 over u du? Isn't that the same thing? Yeah. So I'm just gonna rewrite it like this to make it hopefully pop out a little bit more. Hopefully it should be pretty obvious now how to take the integral of 1 over u. Natural log, right?
Absolutely.
Absolute value of u. Okay, good. There we go. So I'm going to get 5 over 12 ln u plus c. And from there, I got to remember I got to do what? Put it back in, right? I sub it out and got to put it back in now. So I'm now going to be left with 5 over 12 ln absolute value of 4x cubed minus 1 close plus c. Mary Cruz, you feel good, better about these ones? Okay. All right, so let's keep going. So let's try the next one though. So we're gonna try B, and I e over x. Again, it's a puzzle. And in my puzzle, I need to identify what I could use to sub. So which one am I going to use? The bottom one, right? Because if I take the derivative of e to the x plus 4, I get
It is.
e to the x, which is going to be a substitution for the top. That's my key that I'm looking for. So I'm going to say that my u is e to the x plus 4. My du, my derivative, okay, I'm going to get just e to the x dx.
Okay.
Yeah?
So
Ma-
everything is just du at that point.
Yeah, so right there. So let's go ahead and rewrite it. So I'm going to get the integral of, on the bottom I get, what do I get on the bottom?
U.
U. Okay, on top I get
E to the x. Wait, no, du. My bad.
just du, right?
Just du.
So du. So if that's just du, can I just write it like this? 1 du like that?
Oh yeah.
I like writing it like this, 1 over and then times the du, because that clearly identifies being like, oh, it's a 1 over x or a 1 over u. So I could automatically say, hey, that's an ln. Okay, let's go ahead, integrate this one. I'm going to have ln absolute value of u plus c. And then plug it back in. I'm going to have ln absolute value of e to the x plus 4 plus c. Tater tot.
Some tater tots, yeah.
Oh my goodness. Questions, concerns, complaints, conspiracy theories.
Why is there only two?
You got one tater tot. There's a conspiracy theory against you. Got to go in there and tell them.
Someone ate them.
I know, right? Someone ate them all. My nickname is Tater Tot. Okay, I got to come in with a bag of tater tots every day. All right, so right here. So show that tangent, the integral of tangent x dx is equal to either one of these. Both of these or either one of these. Okay, we're going to do a proof. We're going to show that this actually works. I like doing this. So I'm going to have the integral of tangent x dx. But since we remember our trigonometry, right? What is tangent? Sine over cosine, right? Sine over cosine. So I'm going to rewrite it as integral of sine x over cosine x dx. And since this is one of those things I'm looking for again, right? I'm looking to u sub. I'm looking to u sub, and since sine and cosine, I'm looking for the derivative, right? Okay? One's going to turn to the other. So which one do you want? You want derivative of cosine or derivative of sine? Cosine. Okay, that's good. So let's take the cosine. So u is equal to cosine of x. And what is the derivative of cosine x? Negative sine x. So du is equal to negative sine x dx. So there's one slight difference here. Don't I have a positive sign here? I have a positive side. So how do I get rid of that negative right here?
Negative 1.
Yeah, negative 1. So on the other side, this is going to give me a negative du is equal to a positive sine x dx. All right, let's go ahead, put it back in now. So if I get rid of the cosine, I'm also getting rid of the sine. So that's going to give me the integral of negative 1 over u du. So I just put that -1 right there. What can I also do with that -1? Where can I put it? Can I put it out front? Very good. I'm going to put it out front to make my life a little bit easier, right? So it's a negative integral of 1 over u du, which is going to give me a negative ln absolute value of u plus c. And what do we say u is? Cosine. So I'm going to get negative ln absolute value cosine x plus c. And because I know a little bit of trigonometry, can I rewrite cosine as secant? Yeah, right? Okay, so if I were to do that, wouldn't that just be 1 over secant, right? So, but look at the signs that we change here. So 1 over, this is now a positive value. And because ln rules say that if I have this one over here, so it's going to be ln of 1 over secant, because that's still cosine, isn't it? So yes, that's still cosine. 1 over secant is still cosine. I could rewrite that because that's going to be the ln, okay? And that's what I'm going to do with this negative out here. That negative goes there. So if I do that, that's going to turn into a negative ln of 1. What is ln 1? 0. Very good. ln 1 is 0. And then, okay, so now, because it's a division, it becomes a... Do you guys remember the ln rules? So if it's a multiplication, it's a plus sign. Yes? Multiplication, I would put a plus sign here. But since it's a division, it's going to be a minus sign of ln of secant x. Does that make sense, or is that nonsense? Do you want me to go over it again, or Cruz? Do you like it? No? You don't like it? Okay. What part don't you like? Do you remember that this breaks down into 2 separate parts? You forgot that? Okay, so we know there is a rule, so ln of a, actually, I don't have to use the absolute values here, is equal to the ln of A minus ln of B, or ln of A times B is equal to the ln of A plus ln of B. A little bit refresher? Okay. So yeah, that's an ln rule that actually goes with that. So if you forgot it, you know, that was last year, pre-calculus. Everyone tried to forget that year, right? Okay. Oh, okay. So we did some of it. We did some of it also, first semester, just a little bit. Not enough, but you know, that's why I'm going back over it. I don't have a problem reviewing it and stating these. Okay.
It's
So
been like a whole year since I did that.
yeah, we did a little bit first semester, but not enough, because this is algebra and this is stuff that we should know off the top, but just one of those things. Don't worry about it.
I was like back in pre-calc.
Yeah. So anyway, all right, that's where we come up with there. That's the reason why both of these. And so when I distribute this, ln of 1 is 0, so that's a negative 0. And this turns into a plus ln absolute value of secant x. Yes, no, maybe? Kinda?
I'm trying to see what.
You know this is also on the reference sheet too, right? So it's on the reference sheet if you're like completely lost and be like, I'm overwhelmed. I'm drowning in LNs. You ready? Denny, you ready? Denny's ready. Okay, what's the key I'm looking for? The chain, right? Chain rule?
Yeah.
Okay, so what piece I'm looking for? 4 plus x, there we go. Okay? This is going to be a slightly different use of what we're doing, okay? Same concept, but just exact. So we're going to say that u is equal to 4 plus x. There's a reason why I keep saying, I'm like, hey, chain rule should be the key right there. Look at it, chain rule, how would I chain it? That's what I'm looking for. Du is equal to,
X no. I'm talking about 4 dx.
nope, take the derivative. What's the derivative for?
Oh,
Yeah, that goes away, and it's just 1, right? Just 1 dx.
yeah.
Now, this is where the creative part comes into. Because don't I still have an x out here I have to take care of?
Yeah.
So what I'm going to do is I'm going to take this, I'm going to say since u is equal to 4 plus x, x is going to be equal to u minus 4. So I'm going to subtract 4 from both sides, and so this is just an algebra sub here. Right?
Yes.
So that should be straightforward right there. Does that make sense? Okay, so now if I rewrite my problem, I'm going to replace x with u plus 4. Okay? So I'm going to have an integral of u plus 4. Yes? And what is this right here going to be? I took away the inside and I replaced that with u. So this is going to be square root of u, right? So square root of u, but I don't like square roots. I really don't. So I like writing them as exponents because that's going to be u to the 1/2. That's the square root of u, right? Okay. Now what else am I missing? dx is being directly replaced with du. Okay. Distribute.
Can't see that
Distribute it. So that's going to give me u to the, no?
Well,
This is 1 right here, right? So isn't this just 2 over 2? 3 over 2. So u 3 over 2 plus 4 u 1/2. Ah, wow, that's horrible. Now can I do this? Yeah, I can integrate each one of these. Remember, okay, I need to add 1, so that's going to give me u to the 5 over 2, very good, 5 over 2 and I divide by that exponent. But I'm not going to put it divided by 5 over 2 because that's the same as multiplying by the reciprocal. So that's going to give me 2 over 5. Plus, right over here, I'm going to get u to the, 3 halves. U, 3 halves. And then I gonna multiply, right? Multiply by 2 over 3. So that's gonna give me, what's 4 times 2? 8 over 3. All right, you ready? Last thing I have to do is put it back. So 2 quantity 4 plus x raised to the 5 over 2 divided by 5 plus 8 quantity 4 plus x 3 over 2, 3 plus c. Better? Feel good about this? A little? Okay. All right. I'm going to stop here because these next examples have to do with a different types of substitution. So we're going to stop here. We're going to pick it up tomorrow. You guys work on some of your homework, okay? And make sure you all like, share, and subscribe. Hit that notification button, support my channel. Buy stuff from my merch store, Lindsay.
Did you post 5.5 or like waiting later?